What's up, guys? Here we are with our video for 2.8. Okay. Homework from 2.7, just in case we haven't checked that yet. Alright, we should be looking like this. 2 if x is less than negative 3. So for x's that are less than negative 3, we're just going to have the constant value of 2. So we should have a flat line going this way. Open circle at negative 3, 2. Going this way to the left, open circle. We're going to use the equation x minus 1 if x is greater than or equal to negative 1. So we're going to have a solid circle greater than or equal to at negative 1, comma, negative 1 minus 1 is negative 2. So negative 1, comma, negative 2. This is what's going to get you your y, and these are where you're going to start with your x's. So we're going to go bigger, so 0. Put 0 in. 0 minus 1, negative 1. Okay, put 1 in. 1 minus 1 is 0, 1 comma 0. And now we can kind of see the pattern. It's going this way, going bigger than, greater than or equal to negative 1, so we're going this way. Our arrow's going to go that way. So with graphing these piecewise ones, it can help to have little T-charts on the side. Second one, 3 pieces. Okay. Alright, so we have negative 2x minus 1 for x's that are less than negative 3. So we're going to start with negative 3, put that in there. Negative 2 times negative 3 is positive 6, minus 1 is 5. So we're going to go with negative 3, comma 5, open circle. Okay, what's the next number backwards? Okay, smaller than negative 3, we should have negative 4 and negative 5. If we put negative 4 in there, we'll get 7. Negative 5, we get 9. So this is where we started. We're going this way with our dots. Now our arrow is going to keep going backwards because we're using this one for x's that are less than negative 3. In the middle, from negative 3 up to 3, we're just going to use the equation x plus 1. Okay, when you have a between kind of situation from negative 3 to 3, you're going to for sure do each endpoint, and then one middle one just to test. So we definitely need to put negative 3 in, and that's going to be a solid circle. We definitely have to put positive 3 in, and that's going to be a solid circle, and then we'll pick one in the middle. So if I put negative 3 in, I get negative 2. If I put positive 3 in, I get 4. So here's negative 3, comma negative 2, close dot, 3, comma 4, close dot, and another one in the middle just for safety. Let's go with a 0. Real easy to do, right? 0 plus 1, 1. And now I can connect, and all 3 should match up. Okay, if we had 2, you're not necessarily going to know that you're wrong. But if you have 3, and all 3 of them line up, you should be good to go. And then our last one is just the constant negative 7 for x is greater than 3. So still have to do it at 3, 3 comma, negative 7, open circle. And then it's always negative 7 after that. Negative 7, negative 7, negative 7, negative 7. Line going that way. Okay, just dusting off the knowledge here with piecewise. Here's the main idea. Transformations with x squareds and absolute values. X minus 2 in parentheses, we're just going to shuffle it 2 to the right. Out 1, up 1. Out 2, 2 squared is 4. Out 2, up 4. Or we could do your chart, and then just do half of it, really. 2, 0, 3, 1, 4, 4, and now I can reflect those over. X plus 2 is going to go the opposite. It's going to go backwards 2. So we're at negative 2, comma 0 in the middle of our T-chart for our vertex. And then there's no number in the front, so it's just up 1 over 1, both directions. You'll get those same points from a table. X squared plus 3. Okay, we're not going left or right at all. We are going to go up 3. Okay, following the points pattern, out 1. 1 squared is 1, so I go up 1. Out 2, 2 squared is 4. Go up 4. Absolute value of x minus 3, just a vertical shift down 3. So we're starting at 0, negative 3. No multiplier in the front, so it's just a 1. Up 1, out 1 in both directions. All right, 2 times x squared. So we're still starting at 0, 0, no shifting left or right. 2 times. So you could make your t-chart, or we could do it this way. Out 1, normally out 1, 1 squared is 1. But we have a times 2, so we're going to go up 2 times as much, up 2. Out 2, normally that's up 4, but we have times 2, so we have to go up twice as much, up 8. And if you did the t-chart, you get the same thing. Absolute value, negative 3 times absolute value of x. Okay? So there's no left or right or up and down. We're starting at 0, 0. And now this is like our slope. Instead of going up 1, out 1, we're going down 3, out 1 in both directions. T-chart, get you the same thing. Reflect it over. Okay? X minus 1 squared minus 3. We are 1 to the right and 3 down. We're starting at 1 comma negative 3. No multiplier in the front. Nice and easy one. Out 1, up 1. Out 2, up 4. T-chart gets you the same points. Make sure you're starting with your middle, your vertex in the middle. Otherwise, you're not going to get that. Absolute value, left 2, up 1. So we're starting at negative 2, 1. No multiplier, so we're going up 1, out 1, both directions. Okay, we got a little bit of everything going on here. A multiplier, a left right, and an up down. So we're going 1 to the right, 3 down. We're starting at 1 comma negative 3. Our multiplier is 2, so it's positive 2. So that's like your slope. Up 2, out 1, up 2, out 1, both directions. T-chart. Same points. Okay, we have x plus 1 squared minus 8. 1 to the left, 8 down. So we're starting at negative 1, negative 8. Times 2 multiplier. So out 1, and it's usually up 1, but it's times 2, so up 2. Out 2 is usually up 4, but it's times 2, so I have to go up 8. And since I was starting at minus 8, up 8 should put me back to 0, and that makes sense there that we're at 0. Okay, so there's your homework. You'll pass that in when the video's over here. Here's the new stuff. Okay, let's make sure we all have a note sheet. If you're watching online on PowerSchool, there should be a spot where you could download and print the note sheet if you want one. Okay. 2.8, graphing linear and absolute value inequalities. So we're just taking what we were doing before with graphing lines and absolute values, and now we're going to add inequalities. So let's start off with the line one. Y is greater than 2x plus 1. Graph just like it's y equals 2x plus 1. Okay, and the inequality sign, greater than, tells us two things. First thing is that we're going to graph with a dotted line. Okay? If we were doing like on a number line, a greater than, you would have an open circle. Okay? A dotted line is like an open circle. It means don't include the points that are actually on the line. And then greater than tells me to shade up or shade above the line. Okay, so let's check this out. 2x plus 1, that's my slope, that's my starting spot. I'm going to start at 1, go up 2 over 1, up 2 over 1, up 2 over 1. Maybe you want to take it backwards 1, down 2, backwards 1. Okay, we're shading. Well, first we have to draw our line. Dotted line. If this was a quiz or a test, I'm sure we would all use rulers and straight edges. So we have a dotted line. Okay, greater than means I'm going to shade up. Okay, and to me, if I get confused, here's what I do. I take one of my points that's on the line, and I say which way is the bigger y value, because y is greater than. Which way is the bigger y value, up or down? So I'm at, let's just use 1, 3. Would this way be bigger or that way be bigger for the y values? Okay, this way is going to be bigger, up. Alright, and you don't have to color it all in. You just make it obvious on which side's being shaded. Now, if you can't tell which side is above or below, or which side should be shaded, you can always test a point. Okay, let's test a point. You want to test a point that's not on the line. Okay, if you test a point on the line, it's going to be equal. That doesn't really help you out a whole lot. Okay, you want to test one that's not on the line. So 0, 0, there's 0, 0. 0, 0 is not a part of my line. So that would be a good one to test. In fact, that is always the suggested point to test, because it's so easy to do if it's not on the line. If it is on the line, you're going to have to find something else. Okay? Usually try to pick small numbers that are nice to work with. 0, 0 is super nice, because watch this. 0 goes in for y. 0 also goes in for x. 2 times 0 is 0. Is 0 bigger than 0 plus 1? So is that true statement? Is 0 greater than 1? No, that's not a true statement. So this is not the side I want to shade on. Doesn't work. So shade the other side. If this did work, then that's the side I want to shade. If it doesn't work, nope, shade the other side. Piece of cake. All right. So just like less than or greater than are open circles for graphing inequalities on a number line, they're going to be dotted lines, which is like open circles. It's like here's where we're starting at, but don't include that point. Okay, less than or equal to, greater than or equal to, solid lines, just like the solid filled in dots. It means, yes, these points will still work. Okay, so like with this one, the points on the line will be equal, but it won't make y greater than 0. So we're not including those points on the line, because y would not end up being greater than this side. It would be equal to this side. But when it's less than or equal to, greater than or equal to, now it can be equal to, and now those are good points that would work. So that's why it's solid. It's going to include those. All right, let's hit pause here for a little bit, and you can try this one on your own. Okay, let's see how you did. Negative 3x plus 7. 1, 2, 3, 4, 5, 6, 7. We're starting up 7. Negative 3x is my slope. Down 3. 1, 2, 3 over 1. Down 3 over 1. Over 1. And let's go backwards, huh? Backwards 1. Instead of down, I have to go up 3. 1, 2, 3. So we got lots of points. If it was a quiz or a test, straight edge. I just happen to have one right here handy. Less than or equal to, so I know I'm going to do a solid line because it's an or equal to. Okay, solid line. And less than means go down from one of your points. So I'm shading over here. If you did not know which side to shade, 0, 0 would have been a good one for this one. Is 0 less than, negative 3 times 0 should be 0. Is that less than or equal to 0 plus 7? Is 0 less than or equal to 7? Yes, 0 is less than or equal to 7. Shade that side. It was true. Okay, sometimes you're going to be given equations like this. Standard form, ax plus by equals c, but now it's an inequality. Okay, remember what we did with this. You can rearrange this and solve for y, or, okay, you can do your cover-up method, right? Cover up x, 3y equals 12, y is 4. So on the 4, or on the y-axis, we go to 4. 1, 2, 3, 4. Okay, greater than or equal to, so we're going to go with a solid dot. 2x, so we cover this up. 2x equals 12. X is going to be a 6. So 6 on the x-axis. 1, 2, 3, 4, 5, 6. Solid dot, solid line. So here's my line, and that's what we did before with these. Now add the inequality part. Greater than or equal to. That's why it was a solid line. Okay? So these can be confusing and tricky if they're going to work. Okay? It's not quite as easy as looking at this. Which one makes the y value smaller? Okay, this is a little bit trickier, so I would really suggest a test point on these. So again, 0, 0, perfect. 2 times 0 is 0. 3 times 0 is 0. Is 0 plus 0 bigger than 12? Nope. So we're going to shade the other side. This point did not work, so this side is not good. Shade the other side. Ta-da! Math magical. Okay? And some of you guys might have guessed, oh, greater than, go up. Okay, yep, that's true. It worked that time, but it can be tricky if there's like a minus sign in there instead, or if this one's a negative. It just gets weird sometimes. So trust me on this, you're going to want to test one if you're going to do it that way. If you would have rearranged it, gotten y by itself, 3y greater than or equal to negative 2x plus 12, y is greater than or equal to negative 2/3 x plus 4. Okay, we would have started at 4, down 2 over 3, down 2 over 3, still have the same points, and we would have known to go up. But like I said, sometimes it gets a little funny if there's a negative here or a negative there, or both of them are negative. It gets a little weird. Okay? Okay, now what about our most recent stuff with absolute value? Okay? Let's think about what this told me from our 2.7. This is telling me we're going to go 2 to the right. This is telling me we're going to go 1 up. So I know I'm going to start at 2, comma 1. If you want to make a table, remember 2, comma 1 goes in the middle. Okay, and pick some points on each side. 1, 0, 3, 4. Or me personally, I have this over here at 2, comma 1. There's no multiplier in the front, so I know my slope is up 1 over 1, both directions. Greater than or equal to, solid line. So I can go solid line, solid, and I know that's a dotted right now. I'm going to go back, just get my points for my line. Okay. Now, greater than. Okay, greater than or equal to. Again, it's going to mean up from our point. Okay, and we're welcome to test one. Let's see if I put in 0, 0. Test 0, 0. 0 minus 2 is negative 2. Absolute value of negative 2 is positive 2. Plus 1 more is 3. Is 0 greater than or equal to 3? No. Didn't work. So I'm going to shade this side. Alright, and I left a spot here for you to do one, but I see now that I did not write an equation for you. So let's go with y is less than negative 2 times absolute value of x minus 3, and then go with a plus 2. Okay, so let's hit pause here, and then let's see how you can do on your own. Okay, let's see how we did. This is going to go 3 to the right and 2 up. Negative 2. Okay, let's get the center graphed out first. 3 to the right, 2 up. Okay. Now negative 2. That can be like my slope. I'm going to go down 2, out 1 in both directions. Okay. And less than does mean a dotted line for me. Okay, dotted line. Where are we going to shade? Less than for me is telling me on this one down 0, 0. If I put 0 and 0 in here, let's see what happens. See, this is where you got to test these. It's tricky. So with 0, be less than. 0 here is going to be negative 3. Absolute value of negative 3. is positive 3 times negative 2, negative 6 is plus 2 is negative 4. So is 0 less than negative 4? Is 0 less than negative 4? No. Let's double check this. If I put in 0, 0, 0 minus 3, negative 3. The absolute value of 3, negative 3 is positive 3. Times negative 2, negative 6, plus 2, negative 4. Yep, so negative 4 is right, 0 is right. 0 is not smaller than negative 4, so we don't want that. Okay, we want over here. Okay, so just like we had there, it was going to be going down. Last one, story problem. Okay, and we're going to do this one together. Mr. Handke can schedule half-hour and 1-hour study sessions after school for a total up to 10 hours in a month. So I don't have to go up to 10 hours, but I can go up to 10 hours, but not over 10 hours. Okay, write an inequality to represent this. So I'm going to call my half-hour ones x and my full-hour ones y. So I could have x half-hour ones plus y full-hour ones. And as long as that total doesn't go over 10, so less than or equal to 10 hours. Okay, so this is in standard form. Okay, but one of our rules of standard form, no fractions. So to get rid of that fraction, we have to multiply everything by 2. So now that's going to be 1x plus 2y less than or equal to 20. Okay, and then graph it. So we could rearrange it and get into slope-intercept form, or we could do our cover-up method here. And if I'm looking at this, a little bit of just looking at it ahead here, if I do this one, I'm going to have 20, and I can only go out to 10. So we're going to make these all worth 2. Okay, I'm going to make these all worth 2. So we cover this up. My x is going to be 20. We're going by 2s, remember, so here I am. Less than or equal to, so I'm going with solid dots, solid lines. Okay, if I cover up that and solve y is going to be 10. And remember, we're going by 2s, so that's really only 5 up. 2, 4, 6, 8, 10. Solid line. Connect your dots. Okay. Solid line, solid dots going under, less than. Okay, so plug those in. 0, 0 is 0 plus 0 less than 20. Yes, it is. Okay, also think about this. This is a real-world problem. Can I be going into the negatives? Okay, so this is a real-world problem. So we're just going to stay right here in the positive quadrant. Okay, this is where we're at. Because it's a real-world problem. I can't have negative hours. Okay? Alright, there you go. Okay, so you're going to have a worksheet for homework again. I don't like these book problems. Some of them are really good, and then like the very next one is going to be ridiculously hard. Okay, so we're just going to have another worksheet today. Best of luck to you guys, and we'll see you tomorrow.